Hi, this is Thomas with the BCA, and today we're going to talk about how to calibrate a terminal unit. And in this case, we're looking at a dual duct terminal unit with a 6-inch inlet, as you can see. And once you've determined how you're going to calibrate the unit, obviously you don't have to do a traverse. You can calibrate it using a flow hood. But in this case, since we're in an interstitial space, we've chosen to do a traverse with the airfoil. And we measured the duct size. We know it's a 6-inch, so then we're going to mark our measurement locations on our airfoil based on that 6-inch duct reading. And so we're going to do 6 readings. We're going to do 2 holes, 6 readings. The holes will be 90 degrees apart. And then he's going to mark the airfoil, and then he's going to transfer those readings all the way around so that you can see it from every angle. And you know, some people like to tape their airfoils. We just like to use a marker, and then we get a scrubby to scrub those off for other duct sizes that we will traverse in the future. So like I said, you definitely don't have to traverse the terminal unit. You can measure the associated grills with the flow hood. Just make sure you grab a correction factor for the grill types, for each grill type that you measure, just to make sure it's going to be as accurate as possible. And while he's doing this, you could also go ahead and have your second person try and plug into the terminal unit to start accessing the BAS, which we'll show you in just a second. Again, it's all about being efficient as possible in the field. So he's done now, and now we're going to open the terminal unit and plug in. We have a Bluetooth dongle essentially that plugs into the controller, and we connect wirelessly to the BAS. Alright, so once you're connected, you can log in, and you should see this screen depending on the control software that you're using. Then you can, so in this case we have a dual duct, but what we're going to be doing is we're going to calibrate the hot deck side of it. And actually on this project they want us to calibrate the min and max, but for this example we're only going to be calibrating the max side of the unit, which is pretty typical for any job. Usually you don't have to calibrate at 2 points. Typically you only calibrate at the max, and then you'll double check it at the min just to make sure your calibration holds, and generally it will. So once you've logged into the BAS, you're going to drive the terminal unit to its max flow set point. So in this case you could enter the current airflow set point for the hot deck and make sure it's going to be matches your maximum CFM. But these terminal units don't control very well. They actually have, you know, they hunt a lot. So what we've decided to do is actually just manually command the damper. And so once we command that damper and get it close to its flow, it actually stays there pretty well, because the AHU that serves these units is pretty steady, even though the terminal units themselves are not steady. So this is just one workaround if you have badly tuned PID loops in your system. Alright, so now that the terminal unit has been driven to max flow, let's go ahead and start our traverse. And look at that form. I mean, that airfoil is perfectly perpendicular to the ductwork. He's got great eye contact. I mean, it looks amazing. I am stunned at how good that form is. Anyways, and so then we'll just show you a quick little close-up of what's actually going on. So as you can see, he's just aligning those marks with the edge of the hole, and then clicking read, and then it gives him a velocity, and later you'll average all those velocities and calculate a CFM. You multiply the velocity times the area of the duct, which for a 6-inch is 0.2 square feet, and then you'll get a CFM from it. So it's at this point in the video that if you've enjoyed it and you think that we've earned it, please consider hitting that subscribe button and the like button. It will just help us to provide more content for you guys and potentially provide it on a more regular basis. So he's just going to finish up doing the vertical portion of the traverse, and then after he's done with that, he will take a static pressure. Now the reason to take a static pressure is, one, just lets you know what pressure the system was at, but also you can utilize it if you have to do another traverse just to check to make sure that the calibration held. You can utilize the static to see, if you're getting close prior to doing that traverse. It's just, unfortunately, in this situation, since we're upstream of the terminal unit, we can't really utilize the static to calculate a CFM. So generally, a way around that is you can utilize velocities on certain reading points, and it can help you get close, but still you want to follow it up with a traverse. So once you've finished with your traverse, go ahead and start inputting the data into your traverse sheet. We happen to have ours in Excel. Some people use just pen and paper and then transfer it onto the computer later. But just to give you a close-up of us inputting the data in there. And this one actually ended up being about 5% low, which is not bad at all. But we're going to go ahead and calibrate it just to show you that process. So once you have all your data in and you have your two readings, the BAS reading and your reading, then you can go ahead and calculate what your new K factor is going to be. So this is the formula. It's the meter reading over the BAS reading times the old K factor. Now this can change based on the control program that you're using, but for us, this is the equation, and generally this is the equation for most of them. So putting the numbers in, it's going to be 336.7 is the new K factor. So once you put that in, you'll notice the CFM will start adjusting. So look at that AI51 point, which currently reads 164 CFM. It'll average each reading, so it slowly starts to adjust down, and you should see it slowly start to adjust to what we had traversed, which was that 156. And once it gets there, then you can double check your reading by either utilizing a static. In this case, we can't. You can utilize a velocity though, and then you can, to confirm the flow, you can redo the traverse just to confirm that it did in fact calibrate and go to that CFM. All right, now that you're done, go ahead and release the box. Make sure it starts controlling to a temperature set point, and go ahead and plug your holes and then tape them. And this guy's just overdoing the taping, but that's okay. If you like that video, please hit the like button, and if you want to see more content, please hit the subscribe button. And remember, when it comes to terminal units, never, under any circumstances,